Okay, let's dive right into this. Welcome to today's explainer on an absolutely monumental shift in how we create software. We're going on a pretty fascinating journey today. We'll be starting down at the microscopic level, looking at the tiny mathematical text tokens that power artificial intelligence, and then we're going to scale all the way up to a massive macro shift happening right now in the industry. We're talking about multi-agent platforms that can build enterprise software practically instantly. It's called vibe coding, and let me tell you, it is going to completely change how you think about application development.
So, here's our roadmap for today. First, we'll cover how AI understands text. Second, managing AI response variants. Third, the vibe coding revolution. And finally, parallel agents building faster.
All right, let's jump into Section 1. How AI understands text. The building blocks.
It all begins with something called next token prediction. This is the absolute core mechanism behind all large language models. Basically, the AI calculates a probability distribution over its entire vocabulary to predict the most likely next word, or even just a piece of a word based on whatever context came right before it. Now, researchers like Sebastian Roschke point out a really crucial fact here. LLMs don't actually use strict grammatical rules like older software did. Instead, they rely on what's called self-attention mechanisms. By training on just vast amounts of self-supervised data, the neural network learns to predict the next token by spotting deep semantic relationships across the text. So it's not memorizing a grammar textbook, it's predicting probabilities.
Now, what's really interesting about this slide is understanding what exactly a token is. The old way, word-level tokenization, well, it's intuitive, right? One word equals one token. But honestly, it's incredibly brittle. It suffers from vocabulary explosion and out-of-vocabulary errors. Imagine trying to store every single variation of a word, like run, running, ran, in an AI's memory. It takes massive computing power. So the brilliant solution is subword tokenization, specifically byte pair encoding, or BPE. This is the industry standard today. It elegantly splits complex words into recognizable subunits. Take the word unhappy, for example. BPE just breaks it into un and happy. This clever little hack completely solves the massive memory problem of older models and lets the AI process human language way more efficiently.
Moving right along to Section 2. Managing AI response variants, controlling the output. So how do we actually rein this all in? Controlling an AI's output really comes down to a crucial setting called temperature. When you dial that temperature down to absolute zero, the AI's probability distribution becomes incredibly sharp. It triggers what developers call greedy decoding. Basically, this means the model is always going to pick the single highest probability token available, every single time. And if you're using AI to write code or to answer strict factual Q&A, this is absolutely vital. You want maximum factual consistency, right? Not a creative guess.
Adjusting this dial completely changes how the AI behaves. Keep it at a low temperature, say between 0.2 and 0.4, and the output is highly predictable with only extremely minor variations. It essentially acts like a strict fact checker. Now, if you move up to a balanced level around 0.7 to 0.8, well, this is your default for creative chat. It allows for those diverse conversational responses we're all pretty used to. But if you crank it up to high, anything above 1.0, it encourages extreme risk-taking. The AI becomes this wild brainstormer, and honestly, the output can potentially become completely incoherent or totally nonsensical. But wait, here is a highly surprising hardware-level fact for you. Why isn't a temperature of 0 always 100% deterministic? You'd think zero randomness means identical output every single time, for sure. Well, not quite. Out in production environments, you can get server-side concurrent batching variances. And more incredibly, there's this thing called GPU floating point non-associativity. Because GPUs process math in parallel, the mathematical operations actually sum up slightly differently across varying processing threads. So this means that even on the absolute strictest settings, you might only get 95 to 99% similarity, rather than bit-exact identical replicas every time. It's just a fascinating quirk of parallel computing.
All right, Section 3. The vibe coding revolution, from text to software.
Just take a look at this quote. We have entered the era of vibe coding, where simple, natural language prompts allow anyone to describe their vision and deploy fully functioning web applications to production in minutes. That is based directly on insights from Google Cloud and researcher Ajath Profakar. So the crucial point here is this. Because we've mastered next token prediction, and because we've refined those system controls like temperature to manage AI output variants, the traditional technical barrier to software creation has completely dissolved. We are quite literally replacing programming syntax with plain, natural language.
Which brings us to Section 4.
Parallel agents, building faster, the multi-agent climax.
To really grasp why this is such a breakthrough for managing projects efficiently, we have to look at sequential single-agent chat. This old way is honestly like having one single worker trying to build an entire house alone. They do the plumbing, then they do the framing, then the electricity. It's incredibly slow, it creates a massive bottleneck, and it's super prone to these frustrating, repetitive debugging loops where the AI literally forgets what it just built in the previous step. Now, contrast that with parallel multi-agent architecture. This is like hiring 10 specialized contractors to swarm the house and work concurrently. You are managing the project efficiently with parallelism. Instead of sequential frustration, you unlock immense speed, brilliant coordination, and rapid enterprise deployment.
And this brilliantly illustrates exactly what that looks like under the hood. In the real world, platforms like Ajath handle the massive heavy lifting of development by coordinating all these parallel agents behind the scenes, and you never even have to write a single line of syntax. It visually grounds how this technology orchestrates the vibe coding shift right before our eyes.
Let's actually break down what this AI development team is doing. You're directly managing up to 10 parallel agents with designated system names like Maya 4, Raina, Jacob, and Matt, and they are all working concurrently. Maya might be simultaneously designing your front-end UI layout on an infinite canvas, while Raina is concurrently building robust database schemas, and Jacob is instantly integrating secure authentication. Because they totally avoid those old sequential debugging loops by working at the exact same time, it drastically lowers your cognitive load. You just get to step back and act as the creative director, while this multi-agent system deploys a zero-setup, full-stack infrastructure with a shareable URL from day one. It is an absolute game changer. Which brings us to our final thought for today. Now that the technical barriers are entirely gone, and you literally have a team of parallel AI agents waiting for your instructions, what are you going to vibe code first? Really think about it. We have gone from predicting a tiny microscopic text token all the way to deploying enterprise-grade software with a team of AI contractors in mere minutes. The power is completely in your hands now. Thank you so much for joining me on this explainer today, and I seriously cannot wait to see what you build.